So now that we have familiarized ourselves or refamiliarized ourselves with solving a system using algebraic methods, now we're going to use augmented matrices and row operations. So I gave you a little bit of a preview in the last video, but in this video I really want to get specific and talk about what our possible row operations are, what's legal, what's illegal, etc. We have 3 row operations to choose from. The first is called replacement. And replacement tells us that we can replace one row by the sum of itself and a multiple of another row. Really, we can use multiples of either row to do this. So essentially, I might be doing something like, let's take negative 2 times row 2, which of course is going to turn this into -2 and 0 and -18. And perhaps I'll want to add that to row 1. And then this part's very important. I'm going to say the target row. So where is this going to land? When I add -2 times row 2 to row 1, is that going to replace row 1 or is it going to replace row 2? And in this case, let's say it's going to replace row 2. What that tells me is row 1 is still going to be 2, 4, 8. But row 2 is now, if I take -2 times row 2 and add it to row 1, that's going to give me 0 here. And then 0 plus 4 gives me 4 here. And -18 plus 8 gives me -10 here. So that would be an example of replacement. Interchange just means to swap 2 rows. So again, I'm going to show you the proper notation. If I want to replace row 1 and row 2, I'm going to use an equal sign essentially with an arrow on each side. So this is telling me I'm swapping row 1 for row 2. So if I do that, then this would be 1, 0, 9, and this would be 2, 4, 8. And lastly, we have scaling. Scaling, again, is just multiplying a row by a non-zero constant. So a great example here would be row 1. Obviously, these are all multiples of 2. So I can just say, let's take half of row 1. And again, I have to put my new target row, which is, again, row 1. So that means, and again, I cannot use division. Division is not one of the row operations, so I can't say R1 divided by 2. I have to say half of row 1. So half of 2 is 1, half of 4 is 2, half of 8 is 4. And again, nothing has happened to row 2. That stayed exactly the same. So those are the 3 row operations and the proper way that I would like you to show your row operations. This question should look familiar to you because we just solved this in the last video using elimination. Now obviously I want to use augmented matrices and row operations. Now we haven't really talked enough about a good strategy, so really I just want you to sort of follow along with me, and I'm not going to give too much of the strategy away because I'm going to talk about that in the next video. And the video after that. So all of section 1.2 is about here's how to go about solving a system in the best, most efficient way possible. And then what happens when you have variables that don't have a value. But for now, you're just going to kind of follow along with me and do the best you can. So thinking about this in terms of elimination, and again, we haven't talked about this yet, but what I would like is I would really like these values to all be 1s. And then anything that's not there, I like to have them be 0s. So we definitely need these 3 values to be 0s. And whether or not you use these 3 values to be 0s is up for debate, and I'll let you decide the best way that you want to go about that. But for now, you're just going to do it the way I want to do it because I'm the one making the video. So what I'm going to do first is, because I already have a 1 here where I want it, and I already have a 0 here, I'm going to focus first on Let's choose a different color. This guy right here. I want that to be a 0. So every time I have a value of 1, I want everything below that to be a 0. And we'll talk more about that later. So how am I going to make negative 4 into 1? I'm sorry, into 0? I would have to add positive 4. So negative 4 plus positive 4 is 0. How can I add 4 to that? Well, I have to use one of my 3 row operations. The easiest row operation is to then take positive 4 times row 1, because 4 times 1 would give me positive 4. Adding that to negative 4 gives me 0. So I'm going to add that to row 3 to be my new row 3. And that gives me, and notice this is, row 3 is the target row, which means this guy doesn't change. This guy doesn't change. Row 3 is the only one that changed. So what changes? We take 4 times row 1, so 4 times 1 plus negative 4. 4 times negative 2 plus 5. And 4 times 1 plus 9. And 4 times 0 plus negative 9. So that's all for my first step. Now what I want is I'm going to focus on this guy. What do I want that to turn into? I want it to turn into a 1. Well, when I'm just taking something down to a 1, not a 0, but if I'm taking something down to a 1, usually I'm going to use scaling. And that's what I'm going to do here, is I'm just going to take half of row 2 to be my new row 2. So I'm just taking half of row 2. So that means row 1 is the same. Row 3 is the same. Row 2, I'm just taking half. So half of 0 is 0. Half of 2 is 1. Half of negative 8 is negative 4. Half of positive 8 is positive 4. Now what I need, let's see if I've got another color, is this guy to be a 0. So again, when I'm turning something into a 0, usually that means I'm going to have to use interchange, where I'm multiplying and adding together. Now, I could obviously use row 1, but if I use row 1, this guy is going to become problematic because I'm going to probably end up screwing up my 0, and I don't want to backtrack and have to redo work. So what I want to do is I want to use row 2 to help me to get row 3 how I want it. So I'm going to take 3 times row 2 and add it to row 3 to get my new row 3. So what is that going to do? That's only going to change row 3. So row 1, 1, negative 2, 1, 0. Row 2, 0, 1, negative 4, 4. And row 3, I'm taking 3 times row 2. So 3 times 0 plus 0, 3 times 1 plus negative 3, 3 times negative 4 is negative 12, plus 13 is 1, and 3 times 4 is 12, plus negative 9 is 3. So far, so good, because remember, that's what this means, is that x3, 0x1 plus 0x2 plus 1x3 is equal to 3, and that's what I want. All right, let's continue on. Now what I want is, this is where you kind of make a choice. And again, we'll talk more about this in the next video, but I really have to let you in on the secret here. This is essentially called a triangular form, and your book will call it triangular form. And it's triangular because we've got the 1s and we've got the 0s, and quite often we don't have all 1s here. We just have the 0s where the 0s are supposed to be, and then the 1s we can deal with later. That's what your book calls triangular form. This is actually Gaussian elimination, and then going on to the next step, which is making all of these 0s, is Gauss-Jordan. But again, it doesn't matter what you call it because it's still the same thing. So from here, I have a choice to make. I can either, and your book probably shows it to you this way, I can either take this equation and turn it back into an equation, x1 minus 2x2 plus 1 equals 0, and then 1x2 minus 4x3, whoops, I forgot my x3, equals 4, and then 1x3 equals 3. So from here, obviously, I can use back substitution, and I can say, well, I've already found that x3 is equal to 3. I can very easily say x2 minus 4 times 3 equals 4, which gives me x2 minus 12 is 4, which gives me x2 is 16. And again, that's the correct answer. And then I can take 3 and 16 and substitute those back into my original equation. So x1 minus 2 times 16 plus 3 equals 0. x1 minus 32 plus 3 is 0. x1 minus 29 is 0. x1 is 29. And again, I've solved the equation. So this is using back substitution. And instead, you can also, and for now, since we're not focusing completely on the correct algorithm, you could also do whatever row operations were necessary to turn these values into 0. And that's the way that I prefer to do it. But again, for the sake of this video not being 37 minutes, let's not. If I do it that way, what happens here is I would end up with my 3 solutions. And that's why I like it, is I might as well just keep doing row operations until I've actually solved the system. But for now, we can see that we have solved the system again using an augmented matrix and row operations, and in this case, also back substitution. You're going to see the question of existence and uniqueness pop up quite often throughout the course. And when we're talking about existence, we're essentially asking, is the system consistent, or does a solution exist? And uniqueness means if a solution does exist, is it unique? Meaning, is there one solution or are there many solutions? So let's take a look at this one together. And again, we're trying to determine, so far up to this point, we have only looked at consistent systems with one solution. So let's take a look at maybe one that isn't like that. First thing I'm going to do, as always, is write my matrix. 0, 1, negative 4, 8. 2, negative 3, 2, 1, 4, negative 8, 12, 1. And just as we talked about before, I really want this column to end up being 1s, but I've got this glaring issue right here with this 0. So I can't have a 0 there. I have to have, and in the next section we'll talk about all the terminology, but essentially right now I'm just telling you we have to have something there other than a 0. So the easiest thing I can do is essentially swap R2 and R3 with one, I'm sorry, nope, just kidding. Swap R1 and R2, or R3, but I'm going to go R1 and R2. So if I swap R1 and R2, I really haven't done anything except swap them, interchange them, and now I have 0, 1, negative 4, 8 on my second row, and everything else stayed exactly the same. So again, the purpose of that is that I didn't like that I didn't have some value here. Now what I'm going to do is I'm going to try to get that to be a 1. So according to the correct algorithm, I don't need it to be a 1, I just need it to not to be a 0. I like to have a 1 there, so that's what I'm going to do next. So I'm just going to take half of everything in row 1 to be my new row 1. So that's using scaling. And so I'm going to get 1, negative 3 halves, 1, oops, 1 half. And this stays the same. And, oops, that's a positive 4. 4, negative 8, 12, 1. So I have a 1 where I want it, but what I don't have now is I want this to be a 0, because once I have a 1, I want everything below it to be a 0. So I'm going to take negative 4 times row 1, because I needed negative 4 to cancel out my positive 4, plus row 3 to be my new row 3. So row 1 remains the same. Row 2 remains the same. And row 3 is now negative 4 times row 1 plus row 3. So that's going to give me a 0 here. It's going to give me 12 halves, so 6 and negative 8 is negative 2. Negative 4 times 1 is negative 4, plus 12 is 8. And then negative 4 times 1/2 is negative 2, plus 1 is negative 1. Now I would focus on making this a 1, but it already is, so I'm going to focus on making this a 0. So to make that a 0, I'm going to take 2 times row 2 plus row 3 to be my new row 3. Which means row 1 is the same, row 2 is the same, and row 3 is 2 times row 2, oops, all my fat fingers down here making little marks, 2 times row 2 plus row 3. So that gives me a 0 here, that gives me a 0 here, and that gives me a 15 here. So we're going to stop right now because remember what this means. This says 0x1 plus 0x2 plus 0x3 is equal to 15. Well, that is impossible. And because it's impossible, that means no, there is no existence. So this is an inconsistent system. So no solution. And is it unique? Well, obviously, we don't have to check that if there is no solution. So inconsistent system in this case. So here's a question for you to try on your own. And again, be very patient with yourself. Just do the best that you can. We're just learning how to do this. In no time at all, this will just come as second nature to you. But since we're just getting started, again, just be kind to yourself. Do the best that you can. Try this question on your own. When you're done, press play to see how you did. So again, the first thing I would do is draw or write this as an augmented matrix. So I have 1, negative 2, 1, 0. I have 0, 2, negative 8, 8. And I have 5, 0, negative 5, 10. And I already have a 1 exactly where I want it, and I have a 0 just below it, and I would like that 5 to be a 0 as well. So that's the first thing I'm going to do. How do I get rid of 5? I have to add negative 5. So I'm going to take negative 5 times row 1 plus row 3 to be my new row 3. Notice that means row 1 remains the same. Row 2 remains the same, but actually, and I'm going to cheat a little bit, I'm going to do something to row 2 at the same time, just because I notice that these are all even. So it's okay for me to take half of row 2 to be my new row 2 in the same step. So this is going to be 0, 1, negative 4, 4. And then the negative 5 row 1 plus row 3. So negative 5 times 1 plus 5. Negative 5 times negative 2 is 10 plus 0. And then negative 5 times positive 1 is negative 5 plus negative 5 is negative 10. And then negative 5 times 0 is 0 plus 10 is 10. So that was a good first step, or first two steps, I guess, since I cheated just a little bit. And again, I have 1 where I want it, and I've got zeros below it. And I've got 1 where I want it here, but notice I want a 0 above and below that as well. So again, I can do two separate steps. Typically, I would start with that 1 on the bottom, or I might even say, look, everything is divisible by 10, and so I might divide everything by 10. It's really up to you. Again, we don't have an algorithm yet, so I'm just going to take 1/10 of row 3 to be my new row 3 and see where that gets us. And that gives me 1, negative 2, 1, 0, 0, 1, negative 4, 4, and 0, 1, negative 1, 1.
So now I again have the ones where I want it. I need this guy to be a 0. So let's do row 2 minus row 3 to be my new row 3. Row 1 is the same. Row 2 is the same. Row 3 is 0 minus 0, 1 minus 1, negative 4 minus negative 1, 4 minus 1. And then I'm going to, because obviously these are both divisible by 3, let's change colors again. And I'm going to take a third of row 3 to be my new row 3. And again, right now, because we don't know the correct algorithm, if you do it in more steps, if you do it in fewer steps, everything's fine right now. We're just learning. So again, don't be hard on yourself. Then 0, 1, negative 4, 4, and then 0, 0, I'm going to take, negative 1/3, so that's positive 1, negative 1. Now I'm going to continue. I would like the negative 2 to be a 0 as well. So I'm going to take 2 times row 2 and add it to row 1 to be my new row 1. So that gives me 2 times 0 plus 1, 2 times 1 plus negative 2, 2 times negative 4 plus 1, and then 0. Oh, no, just kidding, 8. 2 times 4 is 8 plus 0 is 8. And then my second row I haven't done anything to. And my third row, 0, 0, 1, negative 1. So I'm getting there. Oops. I magically just put a 1 there for no reason at all. So this guy's what I want. These guys are, this guy's what I want, these guys are, this guy's what I want, and I still have to work on the negative 7 and the negative 4. So let's do that. I'm going to do both of those on the same step here. So to get row 2 to have a 0, I'm going to take 4 times row 3 plus row 2 to be my new row 2. So let's keep this guy exactly the same. Row 2 is 0, 0 plus 1 is 1, 4 plus negative 4 is 0, negative 4 plus 4 is 0. And then to get my new row 1, I've got a negative 7, so I'm going to take 7 times row 3 plus row 1 to be my new row 1. So now that gives me 1, 0, 0, and then I've got negative 7 plus 8, which is 1. So my solution as an ordered pair is 1, 0, negative 1. And again, that is the correct solution. So if you got that, great job. If not, that's okay. We're going to keep working at it.